So, joining me now is Allen Bauer, Chief Scientist here at Embarcadero Technologies. Thanks for being here, Allen.
Sure.
So, what exactly is a Chief Scientist, and what's your role here?
It's a completely made-up name. I didn't make it up, but it was, I don't know, I guess.
Well, so what is it, what do you do then with that title, regardless of the title, but what is it you do here?
I do about everything and anything. I kind of look after the entire product. We have specific people that do, have, key roles in specific areas of the product and things like that. But generally, I look after the product at a technical level as a whole piece. So I usually can jump in anywhere and sort of either help out or lend an opinion, or a guidance or anything like that. So there isn't anything that, I don't necessarily cover, anything from the IDE to runtimes to compiler, libraries, everything.
So now you had a big role in the parallel programming library, if that's correct?
Yes, and there are a few things that I do personally get involved in and actually do. So, one of them is the parallel programming library. It had been sort of a project I've been working on for quite a few years, and finally was able to get it to a point where it was usable and shippable and could be included in the product.
I remember years ago talking to you, I think like last time I had you on the podcast, I was talking to you and you mentioned sometime around that time period, mentioned that you were looking at parallel programming libraries, and I was like, oh, is this going to be a feature in Delphi? I'm like, at some point, maybe, I don't know.
Correct, yeah. So yes, I didn't lie.
Yeah. Well, and I know that sometimes, the position I was coming from is a Delphi developer. It's like, I want to know when is this feature going to roll out? And the reality is sometimes it's hard to say, because sometimes these features have a long development cycle before they get put in by product management.
Yeah, they'll have long development cycles, but other industry things might get in the way, or there may be other things that take precedence. It's every day is a list of priorities and stuff. So sometimes what seems to be the priority today can actually shift and change, and everyone knows the industry moves so quickly, so rapidly over the years that, it can change the next day.
Right. So it's not as necessarily how much time it takes to write the library, but how much time it takes for it to be a priority you put into the product.
Well, there's that. I mean, there's clearly the time to develop it and things like that. And then, but see, the thing is that, it isn't just development too. You have to also consider, the testing of the libraries, the integration process, getting it into the product, getting documentation lined up for it, getting, everything sort of around it. And so sometimes, the follow-on processes can actually take more effort than the actual development.
Right.
So sometimes even a one-line bug fix can end up involving 20 different people as you go through it, everything from the QA and the doc and all the testing and the reviewing and all the stuff that goes into it can sometimes involve a lot of people and take a lot of time. And so, when you're involved at that level, it becomes quite apparent. Sometimes it's restrictive and frustrating that's the case. But I've seen over the years that without those kinds of things, the chances of mistakes go up. So if you have these checks and balances and ways of making sure that you are doing the right things, it tends to help the process. Yeah, we still screw up at times, but I like to think that our processes do tend to keep a lot of the bigger stuff from happening.
Yeah.
So.
Well, even when you're moving fast, things happen, but it's like one of those things is like if you knew all the stuff that didn't happen, all the stuff we
sure, yeah. I mean, if you can look at a lot of the finished products and certainly say, they did something wrong there, or it shouldn't have been done that way, or it should have been done that way. But if you saw the process leading up to that, you might go, wow, I can't believe you actually got it done, at all and stuff. So it's all about matter of perspective on where things are. And so, when you look at things from the inside and how the sausage in the sausage factory is being made, it's a completely different perspective.
It's interesting. You did the Code Rage session talking about, I guess it was Code Rage 8, probably talking about the ballistic chronograph you're working on.
Right.
And you, at the time, were using, had written some Bluetooth code. This is before we had the Bluetooth library rolled out, and we were able to talk to Bluetooth on the Android device and Arduino and stuff like that. So you kind of are in an interesting position as far as your ability to use Delphi, because you have a very intimate knowledge of it, but you're able to get in and make changes probably most other people wouldn't get into and make changes on, or? Well,
I didn't necessarily make changes in that particular case, although I think I ended up surfacing a lot of the Bluetooth interfaces that go through the Java native interface, the JNI layer.
Okay.
And so I was able to do that. And, at first I just did it for my own purposes and everything. And so, but once I did that, got them working, then it just made sense to go ahead and commit them, even though, there's a lot of times where I'll access some API that we don't have an explicitly available for in Delphi, and I'll translate it for a need that we have, and then just put it in. And I think it just benefits everyone. So, and that's generally the rule that we have, is that, I need to call this one function, and, that actually is declared in this header file from this API, and, basically, congratulations, you just volunteered to translate the entire file. And so, and that's my approach, too, is like, well, I'm not going to just sit there and piecemeal this thing because it's hard to track, hard to deal with, whereas if I just take the time, translate the whole thing, we have some tooling that kind of helps us, but a lot of it just requires a human to really look at what you want it to do and get it all translated, and then you just put it in.
So you remember when I'd heard that you were working with Arduino, I thought maybe you'd made the Delphi compiler work for Arduino, but
No, because the Arduino is actually depends on, when you're talking about Arduino, there's lots of different things. They have different things that scale all the way between 8-bit microcontroller, single chip microcontroller, all the way up to systems on a chip using an ARM core. So the things I'm working on was actually the simple 8-bit microcontroller stuff. So you're talking about a single little chip that has a CPU on the thing that has 32K of memory. That's 32,768 bytes of memory.
Wow.
For program storage, and 2K of RAM. That's 2,048 bytes of RAM. That includes every space for any kind of programming stack, global variables, structures, anything like that. And then it may have some EEPROM, which is just data storage. You can't actually execute anything out of the EEPROM. So it's a very, very resource-limited device, and it's programmed with a very lightweight version of C, or it could even use assembly language and go straight to assembly language and program it. But it has a lot of things built onto the chip, timers and counters and analog to digital converters and output pins and input pins. And it's designed for making very purpose-driven devices and everything. I use those chips all the time for all sorts of little projects that I have all over the place. So, like I did the ballistic chronograph, and all it was just I did most of the software on a Arduino board, but then I took the chip that was essentially the same chip in a slightly different configuration, constructed a circuit board that I designed, laid out, and etched myself, and then solder all the parts on there, and then took the program and just put it onto that one little device, and it becomes a purpose-built device, and then it has a little Bluetooth module that plugs into it.
Right.
And that's what I use, and then I don't actually use the Arduino board that you can buy. That's actually my prototyping. If I build something with the Arduino, I just use that for prototyping, and I've used it for like 3 other projects, and then I actually program the chips and put them on the device using the same software. So, for instance, the latest thing that I worked on is I have a gantry router, CNC router that I built a couple of years ago. It was a fairly large device, and this past few months I've been working on, I converted it to be a 3D printer, so that it actually it now prints 3D. And one of the things I had to do was create a controller board for controlling the heated bed plate. So whenever you have the heated build plate, where you have the plastic is being extruded onto the plate, that needs to be a heated piece of, and it uses like a circuit board that uses the copper etchings on the circuit board for resistance wire, and it gets hot. And so I have a temperature controller for that, and then the actual extruder itself has to be raised up to a temperature of about 250 degrees C, which is like 480 something Fahrenheit.
Wow.
And then it has to be carefully controlled with either thermocouple or thermistor, and so I have a Arduino project that I built with that does the same kind of a thing. So yeah, I use those things all the time. And then it interfaces with the computer as well. It's got its own display, it's got buttons and stuff, and that's what sort of the latest thing I did with some of that kind of hardware.
So do you think, does it make sense to think about having a Delphi compiler target an Arduino as far as a compiled output to that?
Probably not at this point. You would not really have the same level of what you would expect from a Delphi itself, because the Delphi is more than just a compiler. Delphi is its libraries, its runtimes that it has available, the rich object-oriented nature of the thing, and so it really is more suited toward devices that have a little bit more resources on them. Of course, that being said, devices are getting much more powerful. Even though they're getting smaller, they're actually getting more powerful. For instance, I don't know how many people have seen this, that a popular board is the Raspberry Pi, which is a little tiny, almost barely credit card sized board that has a system on a chip, that has a video output, an HDMI output. You can plug a USB keyboard and a mouse on the thing, and it boots a version of Linux, or you can even boot a version of Android. Well, they just released a new version of that, the Raspberry Pi 2, just this past couple of weeks, and it actually has a newer version of a system on a chip that has an ARM v7 core. It's actually now quad core, has better video hardware, and it boots. It can actually boot Android, either KitKat or something like that.
Oh, really?
Or you can boot Linux onto the thing. And at that point, something like that we could target with Delphi, because it has a gigabyte of RAM on there. You can run 16 or 32 gig flash memory card for your persistent storage. It acts like a hard drive, and you can have this thing running a full-fledged, almost desktop-type system, only it's in the size of a small little, barely a credit card size thing.
Wow.
So things like that, I can certainly see Delphi being able to target, mainly because now that it's got an ARM v7 core, we already target that for Android, so it seems to me that if you boot Android on the thing, it'd be almost trivial to target it, because it would be directly supported. But even if it were, Linux at some point in the future, it's sort of like a hop, skip, and a jump. In conjunction with that, Microsoft just announced that they're actually planning on targeting that particular board with a free version of Windows 10. And it remains to be seen exactly what they're going to provide and everything, but it turns out that the guy that's running that whole operation at Microsoft is a former Delphi guy. He was actually a coworker of mine on the Delphi team, so we know the guy pretty well. So, and we've been in communication with them, and they're pretty excited about us having something with Delphi and everything. So,
yeah.
So we're keeping an eye on that, trying to see where they're going with it, and we're in touch with them. And so something like that's actually kind of exciting. So whether or not it has a full start menu with a desktop, with a full normal traditional Windows desktop, I don't know. If it'll have the standard Windows 32-bit API, I don't know. But I can certainly see us targeting it at some point in the future.
That would be great. Yeah, it's interesting, all these proliferation of platforms we see going on. Apple with the iPhone and stuff like that was kind of the start of it, but now we see the Android devices, and then these Arduinos and Raspberry Pis and such. And I guess Intel has like the Galileo board, which it's more like Arduino form factor, but it's a little more powerful system. Or
yeah, the Galileo is actually another kind of interesting thing, because they already do have a version of a cut-down version of Windows 8 that does boot on the Galileo board, and I have a copy of that. I have one of those boards sitting in my office, booted up, and I can target it today with our standard Windows 32-bit compiler, because it's still just an x86 CPU,
right?
And so it's using a very cut-down Atom type chip. It's very low power, small system on a chip, and so I can actually target it. The sort of the downside to that is that because of the way they cut down the kernel, there's no GUI. It's just command line only. You telnet into the thing, and so all you can do is run a console level stuff. So you don't have a message loop or anything like that. So you can write things out to the console. But for server-ish type applications, there's really nothing. That's kind of what you want anyway. And also, if you're going to be using it to control, because it has I/O input/output things, got analog and stuff. So I do have a version of our runtime that can target in the compiler or compile it. So I do have some Delphi code that does run on that particular board right now. It's not anywhere close to being productized or being available as a direct target. It's more of a research item and everything, just sort of looking at options and everything. A lot of it is just what I do is these kinds of research things, and then present these options to product management and the sales guys, and they can sort of help validate where do we want to go next and everything. So while it's cool, and there's certainly, I can see there being some demand out there, but in terms of us being able to now take it to a product, that requires a lot of effort on getting a lot of the product teams sort of aligned to being able to target that. So it's one thing for me to sit there and hack at the thing myself, and then but it's a long step from that point to actually being a product.
Yeah, I always think that seems like a good application of the 80-20 rule. I feel like I'll see something cool. I was like, oh, this is kind of cool. I'm mess with it a little bit, and I'll feel like I have 80% of the functionality. The reality is I've only really done 20% of the total work that needs to be done to actually make that, or even more.
There's so much more work I even think that's a conservative view of,
it
of
really
life
is.
Too. It's more like, you feel like you've done 20% of the work, and you got the other 300% still to do.
Yeah, it's probably more accurate.
Yeah, it's a lot of effort. There.
Of course, loving technology like we do, everything's like, oh, this would be great to support this and work with this, and you go out and you experiment with it. It seems like a good idea, but then is it really profitable? Is it something that we can do and actually is it worth the investment to get that done? Right.
Yeah. I mean, our product is more than just a language dressed up, thrown into an IDE. It's way more than that. It's we don't, we have to kind of spread our resources appropriately across all sorts of areas of the product. That's both from the compiler and language design, language things, IDE integration, debugging tools, the IDE itself, the libraries. We invest a lot of effort into our runtime libraries, both in just the core of the runtimes, but also in things like the FireMonkey and the DataSnap and the FireDAC and all the different technologies that we target. We also do a lot to maintain and update and continue working with VCL code and everything. So we still have a significant investment into that. And a lot of what we do that doesn't require any kind of GUI access, we make sure that is available to Windows developers, even people still using legacy VCL applications. They can get access to some of the new Bluetooth components and the tethering and the sensor APIs and things like that. And so, I can certainly see, at some points, if we go back to like the Raspberry Pi 2, if they boot Windows 10 on the thing, it's going to have some I/O that's you want to be able to program to, and so they're going to probably provide something, because it has a nice little I/O connector where you can program the pins to do all sorts of things. And so if their design is to target these small embedded type devices and systems that can be built up and using Windows, then that would be all part of it, and we would have access to those in libraries and objects and components from within Delphi itself as well. So it's not just a matter of getting a compiler that targets it, or getting a debugger and the IDE being able to target it. There's also, you want to support it in a way that actually makes sense for that particular target as well. So it's not just those one little pieces and everything. It's not like, you got the compiler and you're done. It's so much more than that.
Sure, yeah. All the stuff that comes with it, whether it be even the non-graphical stuff, there's still a lot in there that has to be support the OS, the different APIs of the system.
Correct. Like, even things like the Galileo, even though we wouldn't be able to support any kind of GUI application because there isn't a video on those things, there's still a lot of stuff, and it's almost sort of like this minimum set of things that you have to actually have in order to be able to target a new platform. And the way things like FireMonkey is written, once we have sort of those minimal things in the platform, the rest of it sits on top of that abstraction and it just starts working and things. So there's actually, as we move between different platforms, a lot of aspects of our product just start working because of we put more effort into getting the low-level abstractions and the targeting of the platform already there. And so a lot of our stuff just starts working. But getting to that point is the difficult part.
So now, you say that you do a lot of different various research projects and stuff like that. What is some other interesting research you've looked into or are excited about as far as just technology in general, I guess?
Well, obviously the big buzzword these things around these days is the Internet of Things, is all of these things. And again, as I was talking about, you're talking about the Arduinos and the Raspberry Pis and the Galileos, and there's another board that's out there that comes out of Korea called the Odroid, which itself is a quad-core 1-point-something gigahertz ARM v7 with a gig of RAM, video, nice little board that it's the same form factor as a Raspberry Pi. And so, all these kinds of things are interesting that are out there, and there's a lot of effort industry-wide that's going into those things. So we're moving from desktops to sort of mobiles and tablets and phones now to actual embedded devices to where, I remember even back in the 90s, people were saying, yeah, you're going to have a computer in your toaster. It's like, well, guess what? We're getting to where you have a bloody computer in your toaster. Even now where you've got people that have the latest version of the Keurig coffee machine where you have little pods that brew coffee. They have DRM that sits inside those that only certain pods can be used. Now they have devices that help crack the digital rights management so you can use your own pods in the things. And so they actually have computing devices that sense the right things in there. So yeah, there's intelligence in these, your coffee machine and everything. And so it's a lot of those things. The health and fitness market is exploding with devices, everything from temperature sensors, heart rate monitors to, little, simple EKG monitors and blood pressure and pulse oximeters and things. All those little devices, they're either hooked up through Bluetooth or Bluetooth LE or some sort of a wireless system. So all of those things are happening, and because of what we're doing now with Delphi, you can start targeting those devices because we have the Bluetooth APIs and abstractions on those. So we have the way to talk to those devices and everything. But we're looking at how can we make that experience even better. And so again, those are the kinds of things that we're investigating and looking at as well.
It's interesting. Not only do we have the like you said, computers and our toasters and our coffee machines and stuff like that are showing up, but the ability for these devices to talk to each other and then data to be collected in the cloud and be used in different ways and stuff like that it's really a lot of little things that are coming together to make the Internet of Things interesting possibility.
Right, and when you say the Internet of Things, it's not only the devices become more intelligent; it's the way they're connected is what's also interesting.
Yeah.
So I agree. Yeah, like I said, you've got the Bluetooth devices; they get connected to a Bluetooth radio that then is in turn connected to the cloud or to some sort of a hub in a centralized location. The home automation market has been around for many, many, many years. I know of home automation stuff for the past 25 years, or even more. I remember seeing home automation stuff.
Yeah.
But now, the rest of these sort of things out there are starting to catch up with that. And in fact, the home automation system is kind of a step ahead in many ways. But they're also kind of on their own, too. And so there's some convergence that's occurring right now, and a lot of new standards and stuff are coming and emerging, and so. But they always kind of joke that the great thing about standards is that there's so many to choose from.
That's true.
Or the only standard is there is no standard.
Yeah.
So.
Well, and speaking of standards, the Nest thermostat was a really huge success, very popular, and Google's bought Nest, and now they're coming up with their own protocol for devices talking to each other called Thread. Is that right?
Correct. Yeah, they have that, and a lot of those things are born out of very similar other things. You've got Ant Plus. You've got, in fact, the original Universal Plug and Play, where you think of Universal Plug and Play as really just about your media player devices being discovered on a network, or being able to talk to your router and being able to open up certain ports on your router through this Universal Plug and Play mechanism. The original spec included home automation, and in fact, a lot of the home automation stuff use a Universal Plug and Play, which is just a broadcast protocol that's on IP. It's an IP level broadcast protocol, and so multicast, actually, it's not even broadcast, it's a multicast protocol because it does go across routers, and so they had in there portions of the spec for Universal Plug and Play was home automation, and in fact a lot of the home automation hubs and devices these days are all based on Universal Plug and Play or some derivative thereof.
Right.
They may support Universal Plug and Play, but they may have their own specialized APIs. Some of them are now putting in REST servers and REST services and everything, which is really just HTTP, using HTTP ports and protocols, but rather than shipping HTML back and forth, you're shipping other kinds of data packets, but you're using the HTTP get, post, put type instructions to talk to those devices, and so all of those things are starting to converge as well. So
do you know much about the new Nest Thread protocol the Thread protocol that Nest is pushing?
I've looked at it, and that's some of the things I am looking into. I think the Nest stuff and their thermostat gained a lot of popularity. First of all, it was in terms of industrial design. If you think about Apple, they're talking about industrial design. It's a fantastically industrially designed. It's heavy. I actually have one in my office. It's heavy. It's solid. And it feels really good. But it looks nice too. But the other thing is that it has its connectivity and things. But there's a lot of other connected thermostats. I have a thermostat in my house that uses REST APIs to talk to it, and I've had it for about 2 years now, and it communicates out to a server, and I have an application on my phone I can read and set my thermostat in my living room at home, or if I'm at home I can communicate directly to it using REST APIs. And so that was even before the Nest actually was around, so it's not like it's new type stuff. I think what that brought Nest more to the forefront is it happened at about the right time, and Google got involved and stuff. I think that was the thing. Now they have smoke detectors and other types of devices, and so again, it's there in the home automation thing portion of stuff, and so they're trying to get some of these things. And a lot of the home automation companies now are starting to support multiple things. Like you have Z-Wave and Zigbee in terms of radio things. You've got the 802.15.12 or something like that, which is or something. I can't remember the exact thing, but it's like their Wi-Fi, which is 802.11 specs. This is another similar spec as well. Bluetooth LE, which is a low power version of it. It's actually easier to use than just straight Bluetooth in terms of both implementing it and programming with it.
And I've seen that some of the demos, the Bluetooth LE has all that discovery and stuff built into it, so it makes it easier to kind of figure out what you're doing with it.
Well, regular Bluetooth has full discovery too, but this one is actually, it's easier in terms of the radios and the modulation that they use and stuff like that than the regular Bluetooth. So there's actually other technologies that are similar that predated Bluetooth LE that Bluetooth LE kind of halfway adopted, and so there's similarities there. I've even seen cases where where a particular radio technology that's not Bluetooth LE is actually able to transmit and modulate properly a Bluetooth LE discovery packet, and it gets recognized, and so you can create beacon with that, and so a beacon technology can be done.
Actually, why don't you explain a little bit beacon technology? We hear a lot about that. A lot of people are still confused about exactly what that means.
Yeah, if you boil it down to its bare minimum, what it is that it's a transmit-only discover packet that basically is the same, the normal Bluetooth LE discovery packet, which is simply a, here I am and what I, and here's what I do. But it's a specially formatted packet that follows the simple discovery protocol. And within that packet is some arbitrarily defined fields of information. One definition of what those fields are is the iBeacon protocol from Apple that they've specified. But there's also others. There's one called AltBeacon. There's other custom beacons. I know Qualcomm, they have their own set of beacons as well through their gimbal little beacon things. And they can all be programmed to do different things. But at its core, it's a transmit-only Bluetooth LE signal. It just periodically will just sit there all day, every day at a certain interval, spit out something. If somebody receives it, great. If not, it just goes into the ether and it's gone and stuff. So the idea is that you get that information, you can identify that particular physical beacon device, then you can look up elsewhere and correlate that thing to where it's physically located and or any other information about it, and then you can use that information for things like geozones and stuff like that. Or a lot of times, a lot of the examples they show, you walk into a store or you go down a specific aisle of a grocery store or of some store, and it tells you here's the sales going on in this aisle. I mean, little things like that. The other things they can be used for is zones within a building and stuff, so you can tell you where you're going, so you can actually say, if a large office building, I need to go to office such and such, it could give you say you're here, and I can guide you from where you're at to get to the right places. But at its core, it's just a simple data transmitter that transmits a packet of a specific size with a specific format, and then you just listen for it. And it's essentially a Bluetooth LE discovery packet.
Okay. Now, there's other similar technologies. NFC, or not NFC, but RFID was really big. A few years ago was the idea. It was kind of a similar idea. Was this something you could discover? And
RFID is a little different in that it's actually an excitable technology. And what I mean by that is that it requires a transmitter to sort of enable or turn on the device. And it has no battery, has no its power on its own. And what it does is it induces a current into the device that can charge up a small little capacitor in there, and at the same time fire up the chip, and then when it responds, it then discharges the capacitor and pumps back a signal, or it pumps back a little bit of an inductive interference with the antenna that's using to detect it, and it can read data back from it at that point. And so it's much more passive type thing, and so that's why they're so cheap. They can be, the chip and everything can be printed on a little tiny slip of super thin paper or super small and encoded with some fixed amount of data, which is they all generally do. They have really no computing knowledge at all, and then they can be slapped anywhere and done anything, and then as they approach an antenna, they can go through either a tunnel or near an antenna that will detect the device. They're very similar to those little security tags you get stuck on packages of stuff, so that they seem to disable it as you check out at the checkout counter.
Right.
You go through the detectors at the door. Those are RFID type devices.
Okay.
So that's the kind of technology it is, and it's been around for decades, literally.
Yeah.
So
okay. And then where does NFC fit in that?
Well, NFC, obviously stands for the near field communication, and but that's a little bit more active of a thing. But it's a super low power. It's even lower power than Bluetooth LE, because it's designed for actually almost physical contact between two devices, and so it's so low power that it does not propagate very far at all. And so it's used by the Apple Pay system.
Right.
It's used by the Google Wallet. Like my phone has an NFC, and I can have my Google Wallet and does the same thing as Apple Pay and everything. And so they have little NFC, the little terminals at the store and everything. You put your phone up next to it, and it initiates a transaction at that point.
Don't they have like NFC stickers and stuff like that as well? Or those have a battery in them? Or are they completely passive, or how does that work?
They have some of those, and again, the NFC sort of mixes both the passive and active type.
So it kind of builds on top of the RFID type idea.
It sort of builds on top of that, but it's also it can communicate back and forth. So,
okay. How long have you been working on Delphi as a product?
Well, I
was going to say version 1. You were the whole
I was before version 1. So,
before version 1.
Yeah, I mean, I was involved with the original development of the product with all of the original developers. So I think for the development team, I think I'm the only one that's still, the other team members have moved on to other things and stuff, but I think I'm the only one. So.
And then you were involved in Turbo Pascal before that then as well?
Right. I joined what was Borland International at the time in 1992, in January of 92. So I've basically gone 25 years now, or 23 years. And the first product I was actually involved with in some way was Turbo Pascal for Windows 1.5, but the first product I was actively involved with was Borland Pascal 7, which is the first version of Turbo Pascal that introduced protected mode, 16-bit protected mode programming, and so I was heavily involved with that. Did a lot of work on the IDE and the libraries, and if anyone remembers the Borland graphical interface, or BGI libraries, I did a lot of work on getting those working in protected mode, changed the spec, got it to work both the same BGI driver binaries will work in protected mode and real mode. I worked closely with the DOS extender guys. They were in the pod across the hall from where I was, and so I worked with them. I guess I have to say that one of the guys still on the team I worked with when I first got here, and that's Eli. He actually lives out of in Massachusetts now, but he works remotely. He's under a lot of snow right now, but but I worked closely with Eli, and he'd actually left the company and then came back a couple of times, and so but right now he's the lead architect guy for the C++ side of the product, the C++ tool chain, the compilers, and linkers and everything. So I've worked with him closely as well back then, and so that was the first product I worked on. Did a lot of work on TurboVision, which was sort of the predecessor to the Delphi VCL library, but it was all DOS and graphical mode.
I remember TurboVision. I used that one.
And then I was heavily involved with getting a 32-bit version of TurboVision, and we were looking at targeting 32-bit VCL, not VCL, I'm sorry, 32-bit TurboVision and a 32-bit Turbo Pascal. I had worked closely with the guy that was writing that compiler. Borland purchased the compiler technology from a guy out of Germany that was a Turbo Pascal compatible compiler that would compile Turbo Pascal code, but it was targeting the Atari ST.
Oh, wow.
And which was a 68,000 CPU. And we purchased the compiler from him, but then we contracted with the guy who then wrote our x86 backend, which we still use today, both for C++, 32-bit, and Delphi 32-bit on Windows, and also Mac, 32-bit Mac, and we used it for Kylix as well. And so he wrote that particular backend, and he was with the company for quite a number of years throughout Delphi and some of the early C++ stuff and everything. He actually, when he left the company, he ended up going to Microsoft, and last I heard, or what I think he worked on, was the just-in-time compiler for .NET, and a lot of the optimization stuff that they did in the .NET core and kernel. So he worked somewhat tangentially with Anders Halsberg after he had left the company and went to Microsoft as well. So
okay. So what's some things you'd like to see? You think would be interesting to see in Delphi in the future, not near future, but far future, things that are not attached to any particular releases, obviously.
Well, I mean, a lot of the stuff that I'm working on now is, is obviously stuff they would like to see in a product release in the future. That, like I said, it's still in the early design phases. Like I said, we're looking at, Internet of Things, supporting all these devices in some way. Either we're running and communicating to these devices, or we're actually working on those small devices. Like I said, the Raspberry Pis, the Odroids, the Galileos, and all that stuff in some form or another. So those are the kinds of things I'd like to see. But again, ultimately, it's going to end up depending upon both the market demand, and our own bandwidth of what we can do and everything.
I give you asking occasionally about the possibility of Arc being on the desktop. What do you see possibilities of that or implications of that?
At some point, yes, but I don't really have any time frame at all or anything at that point. So, I think it's something we want to continue to look at. On Windows, it's probably going to be a little bit more difficult to do that, mainly because of a lot of the legacy we have. But I could certainly see Arc being available on other platforms, desktop-type platforms, Mac OS. If we do a Linux targeted platform with or without a GUI, probably without a GUI initially. For server-side stuff, we certainly look at probably being Arc enabled. Windows, because of a lot of the legacy and things, it's going to be much more difficult to move to that. Not so much difficult for us and everything. It's a lot of just the ecosystem out there is not quite ready for it.
Right, you got customers have existing code. We want to make sure it's going to.
Sure, but people have existing code. They're moving to Arc just fine now. We have a lot of existing code and everything. A lot of it is just people are relying on libraries just that are no longer being maintained and stuff. So they may be relying on some open source library that nobody maintains. It just happens to be compiling over and over again, and it's just working fine for them. But they're not actually developing it or maintaining it themselves. They just are using it. And so there's a lot of customers that are doing those kinds of things as well. And so, we have to take a lot of that stuff into consideration. Yes, I would like to see us move to that in the future. Also looking at other new language type stuff. Like I want to move to a much more unified rooted type system to where literally everything can be treated as an object.
So similar to how Java is within C#.
Java, C#, a lot of those modern languages and everything, even things like Python. It's a unified object model and things. So, it can be done.
Right now, we have the ability on integers and strings to have with the helper methods. Right, we can say the helper methods to say to string to integer.
Correct.
And such, but actually moving it to actually be
correct. Yeah, and the sort of the helpers for the intrinsic types was a way of syntactically achieving that similar goal. And the ultimate goal being is if we move to a rooted type system, then integer becomes an object that has a method called toString and that you can call it. And so those helpers would disappear at that point, but then there would be the same APIs available, so your code would not change. So if we went with a rooted type system, then you could just move your code there. But what it would also give you is the ability to treat all objects as objects, all entities as objects. And so, using techniques such as, the .NET calls it, boxing and unboxing, which is essentially moving an intrinsic value or a simple type off into the heap and then back off to the heap and everything. So you can box an integer into an object and then treat it as an object. Then you can unbox it to get the integer back out.
Okay.
And everything. So, So, contrary to what a lot of people think when you're talking about a rooted type system, you still have simple types. You know, a 4-byte integer still is 4 bytes. It doesn't have, not every instance has all the overhead of a virtual table and all the other stuff that's there. It doesn't have the overhead of an object when you're treating it as an integer, as this intrinsic type. But the compiler knows specifically about them and then can treat it when it needs to as an object. And so, there really is not any extra overhead over what we're doing with helpers today compared to having a rooted type system in the future. So effectively there will be no real downside to doing that in terms of performance and storage size and code size and things like that. But you do get the upside of being able to now have a list of T objects, and you can have integers in there and floats and disparate types, and then you can figure out what those things are. It's almost like a super variant kind of a thing.
Sure.
And so you can then have that. Even things like records and arrays can be boxed up at that point, and they become, they have their own object that then can wrap things up. So, a lot of those things are sort of manufactured on the fly by the compiler as needed as well. So,
So I know before you've mentioned that, like, for example, with the parallel programming library, that introducing it as a library as opposed to a language feature first is a more flexible way of dealing with it and working with it, and then later on, if it makes sense, it could become part of the language. That's kind of
correct. Yeah, and that's I still hold that as being the case, because when it's a library, you can then it becomes, you have much more flexibility in changing and evolving it. But as soon as you lock it into a language feature, the semantics of that language feature can no longer change. And so you either have to then abandon that particular language feature and introduce a new language feature to introduce a new semantic. Whereas with a library, you can easily deprecate a particular section of the library and introduce a new semantic without having to deal with all sorts of existing code and having the, all that stuff in there. At some level, even compiler integrated language support requires a runtime bit of library work. And
right.
So ultimately, this particular work may fold into the addition of language support, but it would be leveraging essentially the library we already have.
Yep.
So.
All right. Well, I'm going to go ahead and let's wrap this up. This is great, a great conversation. I really enjoyed it. Hopefully everybody else has as well.
Sure.
I know you got lots of stuff to get back to, so appreciate your time. Thanks for all that you do, Alan.
No problem.
All right. Take care. So anyway, everybody, thanks for listening in on this special conversation with Alan here. And we going to get back to the rest of the Delphi week here. Let's see. Neville says, don't move Windows version to ARC, just provide it as an option.
How would we provide it as an option? That's kind of question.
He says maybe have a different base class, T-object ARC or something.
No.
Oh,
no,
yeah.
That's a... So. I've gone down this thought experiment many times, and as soon as I start presenting that sort of thought experiment, a lot of those optional things fall over quickly. I can go through them, if people are interested in it, but essentially, because you're dealing with a compiled programming language that's compiled into specific libraries and everything where the code is already compiled, so you have a DCU file that's locked into a particular thing. Even if you're using different base classes or not base classes, they become not type compatible anymore. And so you have this whole subsection that's ARC and one that's not, and everything. It's different than just interfaces and things like that. It creates this whole bifurcation in the whole object model. And then do you even have a common base class at all?
Right.
And stuff.
Yeah.
So the other thing is that if people have said, well, just make it a switch. It's like, well, okay, I compile DCUA, it requires DCUB. DCUA is ARC, DCUB is not ARC. How do you reconcile those two? Well, you may not have access to all the source code, so you can't actually just recompile those things. And what if it's not designed for actually allowing ARC? It's the same, it's the same recommendations that other systems that have some sort of automatic reference counting. They say don't intermix these things and everything, even though they may say, yeah, you can kind of turn this on and off, but their first recommendation is ignore that option and turn it on.
Sure.
So there's, short of that, then we ship completely copied different sets of libraries between the two to where you can't use one with the other.
Yeah. Well, actually, I do have one last question for you. I forgot an important one.
Yep.
iPhone or Android for your phone?
My phone?
Yes.
I have an Android phone.
Android phone?
Yes.
Why is that?
Because I just didn't want an Apple.
Oh, okay.
That being said, my daughters and my wife, they have iPhones. So
They have iPhones. Okay.
And my two sons are Android, and I'm Android. So
Interesting. All right, great. Well, thanks again, Alan, for your time.
okay.
All right, we'll talk to you later.
All right. Bye.